Hello students, you are welcome back to Dr. OJ's tutorial class. Um, we want to distinguish between step functions and simple function in this video. We've discussed how we relate step function to Riemann integral and how we relate simple functions to Lebesgue integral. So this time around we want to see the difference between the two of them. So let's write. A step function is a function that takes only finitely many distinct values and is typically defined on the real line R. Real line R. Can you see? Or a subset of R. It could be or a subset of R. So it could be defined on the real line R or a subset of R. It is written as let's say f of L is equal to the linear combination of characteristic function of is AI in AI is a collection of subset of R. I is 1 and CI is distinct, must be distinct. It could be a set of real number or complex numbers. So let's define the parameters where CI are real or complex constants. I told you that before. Complex constants. I told you that before. And the AI are disjoint measurable. They are disjoint measurable subsets of R. Why chi AI, you already know this, is the characteristic function of AI, which is 1. You don't need to define that. We already know that. It is 1 if x is in A and 0 otherwise. So these step functions, they are commonly used in elementary analysis and can approximate more complex functions in various ways. They are commonly used. The step functions are commonly used in real analysis. They are commonly used in real analysis. It's elementary real analysis. And can approximate more complex functions in various ways. Okay, now about simple function. This is clear and self-explanatory. Let's look at simple functions. Let's look at simple functions. Okay, let's look at simple functions. A simple function is a measurable function. That takes that takes only finitely many distinct values. E.g., you can have, let's differentiate, that is, let's say h taking x to a set of real numbers or complex number, it could be complex or real. It is written as h of x is equal to, linear combination of the constant together with the characteristic function, set of linear combination. So, like we said, AI are real or complex. They are real where AI are reals or complex constants, just like we have in the previous one. And EI are measurable sets. They are measurable sets, in the given measure space. Which I mentioned some time ago. Measure space could be X, the set itself, the collection of subsets, and the measure on it. Okay, so that's that about that. The difference between them is just that the domain of a simple function is a general measure space X. This guy, that's the difference. The domain of a simple function is a general measure space. This, you don't necessarily the real line. Okay, then this makes simple functions fundamental in Lebesgue integration, as they approximate more complex measurable functions. So on this note, we want to draw the curtain of difference between simple function and step function, simple function and step function. So in the next video, we shall look at a simple proof. We'll be asked to prove something. A lot of proofs are there. We will start proving how to establish some relevant proofs. So we shall look at that in the next video. Don't forget, click on the notification button so that each time I upload a video, you'll be notified. Thank you.